Welcome to week 5 in Math 52. We're talking about percentages this week. And the textbook chapter is just the 5th chapter, percent. As always, I'm going to go over my Math 20 notes to focus on the common confusions, things that you might not have had explained to you very well before. Do as much self-guided homework as you need, then turn in the graded work. One of them is a Math 25 topic that's optional. That's how this week will go. But let's start. I'm going to assume that your big worry at the end is how to do percent word problems. Everything will be building up to that. We had a colorful page last week about proportion word problems, where we figured out that the arrows had to go the same direction. So if you don't remember what that is, let me show you briefly. So this one, remember this stuff? So that was sort of our magic page last time. And hopefully this made the proportion word problems easier for you to change from English sentences into math equations. So you could do things like that. So with our new Jamboard, we don't have a single magic page this week, but we're going to build up to how to do percent word problems that way. The first thing we have to talk about is just how percents work. So let's start with that. If I have a rating scale and move this onto our Jamboard. Let's talk about how much we like things. Let's rate jogging on a scale of 1 to 5. Let's call something out loud.
Uh, 4 out of 5.
4 out of 5. Okay. How about banana runt candy?
3 out of 5.
3 out of 5. That's amazing. I almost never made anyone that's in the middle. Those 10. The reason banana runts are there is because people love or hate them. Okay, elevator music.
2.
2. Okay, if we changed things to a scale of 1 to 10, what should we do with these numbers? Are they just doubling, or do we have more refinement than that?
Double.
Double. Everyone okay with that? How about a scale of 1 to 100? Now we have a lot more room for being specific in how much we like things.
Triple.
Going from 10 to 100 is about a times 10. So maybe what we want is just 80, 60, and 40, but maybe we want something like 75 or something like that. So we have options. Okay, actually, I don't care how much we like banana runts. That's just there to show these scales. The point is that this scale here, we have a name for. It used to be called per cent, per meaning out of, and cent meaning 100, like 100 cents in a dollar. But since English is a language that takes other languages and mugs them in the back alley and steals their vocabulary, this eventually became squished to be percent as one word instead of 2 words, and that's how we get percent today. Okay, oops, I'm over here. So percent means out of 100. And we are math people. We know lots of ways to do out of 100. And by lots, I mean 4. So let's look at 47%. We could write this as 47 divided by 100. All I have done is taken this percent symbol and replaced it with divided by 100, because that means exactly the same thing. I could take 47 and do 2 decimal point scoots to the left and make it 0.47. Because we've seen earlier in class that divided by 100 is the same as 2 decimal point scoots to the left. So again, I took the percent symbol and I replaced it by something else that means the same thing. I could take 47 and write it as a fraction with the denominator over 100. That also means 47 out of 100. Or I could take 47 and write it as 47 times 1 over 100. That's another way to do out of 100, because that's the same thing as that, right? So when we are dealing with percents and changing things in and out of percent format, the game is to think about our situation. What are we trying to do at this particular moment? And one of these 4 things will be the convenient thing to do. Which one we pick will be different based on what we're trying to do this moment. So this is like your magic cheat sheet for the next few minutes. Everyone okay with me so far? Okay, so if we were in Math 20, we would be doing this nice and slow, but we'll go a little faster. I've already shown you shading in things. The very first class day, I stole this grid and we tried shading in 47% and things like that. Let's do it again though, because we did it with rounding, and this will be slightly different conceptually. So if I wanted to shade 47%, how much would I shade? The whole thing is 100%.
4 rows, like 4 whole rows, and then just 7?
Yes. Okay, pardon my art. Everyone okay with what I did? What if I wanted to shade 4.7%? I could shade the 4, that's easy enough. Then what happens?
You could do like a little bit over half of a box.
Yes, a little over half of the next box, 7/10 of the next box. Everyone okay with that? And then how about if I did 0.47%?
A little bit less than half of 1 box?
Yeah, it's not 1%. 1% would be 1 box. It's almost 0.5, almost a half of 1 box. So it's perfectly fine to have percents that have decimals in them. That's not broken in any way. That just means we're shading parts of these boxes. Okay, so our first thing to do is a percent to decimal. If I want to write 47.1% as a decimal, I want to take that percent symbol and replace it with something else. Which of these will be the easiest thing to replace it with?
Would it be the second one?
The second
The 2
one.
decimal points?
Yeah, scooting is really easy. Whoops, not. Everyone with me so far? I took a percent and I said, I want to replace it with something else that means the same thing. So I did. Ta-da. Okay, what about decimal to percent? This is conceptually a little bit trickier. I have 0.75. I want to put in a percent symbol, but the percent symbol isn't there. So I could put it in, but now I've changed the number. And if I change it, I have to do something else to keep things fair. Just like with fractions, if I multiply the bottom by something, I have to multiply the top by something too. So I need to do, if I put in a percent, I need to do like the opposite of percent to balance things out. So which of these is the easiest to do the opposite of?
Multiply.
Multiply. I could do times 100, but there's an even easier one.
Divide by 100? No.
No, here's your hint.
Could scoot the decimal point the other way.
Yeah, scoot it the other way. If left twice is the same as percent, right twice is the opposite of percent. So if I needed to, I could put a decimal place, but I don't right now. Similarly, whoops, no, I thought I had cleared out everything. Oh, okay. If we have 0.04, and I wanted to make that a percent, I would go right twice, and I would get 4%. Everyone okay with how that works? So I need to have something to say, since I will be doing this a lot. So the thing I will say is RIPLOP. RIPLOP stands for right into percent, left out of percent. It doesn't say scoot twice. You just remember we're always scooting twice. But if I'm going out of percent format, I go to the left. If I'm going into percent format, I'll go to the right. So right into percent, left out of percent. Why is it always 2 scoots? Because percent is always about 100. And 100 is always 2 scoots when you times or divide.
Could you do an example where it's like 0.04, like it goes past the, like maybe C on 90, where it goes past 100?
So same thing, I'm going to scoot twice and get 37.5%. My art is poor. That work? Okay. If you need more practice, all of these always have answers here. Come back to where we are in the Math 20 notes and read them more. Fractions. Oh no, fractions. Okay. So if I want to change a percent into a fraction, the decimal point scoots is no longer the easiest one. I want to take my 42% and again, replace the percent with something else. So which of these will be the easiest thing to do to make a fraction?
The last one, like times 1 out of 100.
That works, but that's not the easiest.
The third.
The third one, just write it over 100. I would be done. I've written it as a fraction, mission accomplished, except for that annoying rule that fraction answers don't count as finished unless you reduce them all the way. Okay, questions on this one? Guess what's next? I see people's lips moving, but they forgot to unmute. Fractions back to percent. Okay, new slide. If I have 7/8, I could try and do something with the fractiony ones, but it's going to be a lot of work. You're welcome to play around on your own and see how this might work, but it doesn't work well. So since none of those are immediately useful, then we're just going to say, that's all silly. I can take 7/8 and write it as a decimal. The fraction bar is just like division. Use my calculator. We don't need to worry about doing this by hand. And then, we can put on a percent sign if we do the opposite of a percent sign, just like we did before. Whenever I do this now in the future, I'm going to write over here riplop, and we are going right into percent. Going from decimal to percent is so quick and easy with riplop that that's more efficient than any sort of fraction thinking. So we'll go right away using division on the calculator into a decimal and then riplop and be done. So that's all for part one. You know how to make decimals into percents and back again. You know how to make fractions into percents and back again. You already knew how to make fractions and decimals go back and forth. So now you can switch things around any way the problem requires. Questions on that before we continue?
I guess my only question is when would the last scenario be useful?
That one is when you have I'm going to put it over here in red. If I say, what is 8 3/7% and change that into a fraction, then that's when I want to use the last one. And you'll see why if you try doing percent to fraction this way. If you try and take this thing, get rid of the percent and put it over 100, that's kind of messy. It's easier instead to do a times 1/100, make this into an improper fraction and multiply like you know how. But that happens, that's sort of like advanced math 20. We don't care about that. We have other things in math 52. Okay, you go away so we don't confuse people in the future. Good question though. Okay, do. Next topic. If I am using the simplest type of word problems, we'll have percent of something. And I don't want it to say none there because that's going to confuse someone. That's just saying in the Math 20 textbook, there's nothing there. Okay. So the word of means multiply. You know that, you've done lots of word problems. If somebody says tickets to an amusement park cost $25, a family buys 5 of them, then I'll take 25 and I'll say 5 copies of 25 is 5 times 25, get 125. So the fact that of means multiply is something you've seen before. That's still true when we have a percent. It doesn't change just because we make a percent. So if we say, what is 40% of 20? That's 40% of means not 20, 200 of the 200. I'll go riplop. Are we going into or out of percent?
Out.
Out. So we'll go to the left. So 0.4 times 200. Oops, get rid of that. 80. And we got our answer. So of means multiply. That's the lesson for this line. Let's make it a little trickier. So now we will work backwards. A candy bar that normally costs 75 cents goes down in price to 15 cents. I could have written my arrow straight down, but since I am used to reading from left to right, at least in English, then I always sort of make a flow of what's happening going across the line. So you can make it straight down if you want for your picture. I'm just explaining why I draw. Whoops, and I drew my picture wrong. It's not going down to 15 cents. It's 15 cents off. It's not asking me what the new price is, but you can tell me what's 15 take removed from 75.
60.
60, yeah. See who's here, who's just showing me a black name on Zoom. Okay. So it's going down 15 cents. That's great. We want to know what's the percent of that decrease. So 15 is how much out of 75. What are we going to do arithmetic wise then? Add, subtract, multiply, divide.
would you multiply? Because it says of.
That's a good guess, but it's not going to work.
I think it's dividing.
It is. If I don't write it with the words out of, which was there just to trick you, sorry. If I wrote it like that, does that make more sense? 15 is my part. And 75 is the whole amount. It's like I got 15 out of 75 pieces of brownie or something like that. And then fraction bars, we just saw, are like division. So here we're doing 15 divided by 75, whatever that is. 0.2. That's a good answer. I like 0.2, but it's not a percent. So we have to do some more riplop. Are we going into or out of percent?
Into.
Into. So we'll go to the right and we get 20%. Questions on this slide? This percent change happens so much that we get a formula for it. Normally, I'm not going to encourage people to memorize formulas. Really understanding what's happening is better. But percent change happens so much that there we go. You take the change and you divide it by the original amount. In this case, the 60 doesn't matter. That's not the original amount. When we talk about a change, the baseline of comparison is always the original, not the new thing.
So like if you had a word problem that said like the candy normally costs 75, but it's on sale for 60 cents, you'd have to just subtract it to find the 15.
Yes. There's no new in this formula. You'd have to subtract it, just like you said, to find what the change is. So if you keep reading here, then it will talk about I guess it doesn't. Oh, it should talk about that. Sometimes they hide it. This is sort of that. So what we looked at first was the problem said, I want the, whoops. Does the problem ask for the change as a percentage as a number? If it wants a percent, like we just did, then does it show or hide the change as a number? In this case, it showed us the 15, but if they hid it, like Journey said, and gave us the new price, then we'd have to subtract. The other side here is if the change, it asks for the change as a number, then does it want that number or combine it with the original? What I mean by that is, let's do this problem. That's going to be too wide. One moment. So a painting originally worth $200 increases in value by 3%. What is the new value? I'll have to find 3% of 200. We're going out of percent. So do they want that $6 as the answer? The question could have asked, how much did it change in value? But this time they want me to combine it. They want, what is the new value? I have to take the original 200, which hasn't gone away, and add the 6 to get 206. So this picture up here is your sort of be careful of things picture. If it's a percent, of something, then are they asking you for just to find the percent of something and stop? Or do they want you to put it back with the original amount? And if it's a percent change, then do they give you the change to plug into the formula? Or do they give you only the old and new values and you have to subtract to find the change? Okay, that had terrible flow. I'm sorry, I'm not used to going at the faster than math 20 pace, but I think we've got it. Okay, so we want a more general approach. It's nice to think about these very most common situations in life, finding the percent of a number or finding a percent change. But if we actually are sitting down to do a whole page of random percent word problems, which only happens in math classes, right? On the job, there will always be some sort of contextual trend for what you're doing. But just for this week, when you get a whole bunch of math problems with percents and homework, we want a more general way to do things. I'm going to keep that there. So I can't show you one cute slide like we had for the proportions to help you set up the word problems, but I can show you a few things that will build on each other. First, I'm going to define a percent sentence. This is my phrase. You're not going to find it in Google or in a book usually. A percent sentence is a short word problem that has the words is, of, what, and percent. What is 30% of 90? 60% of 12 is what? Something like that. We're going to learn how to solve these, and then we're going to learn how to translate longer word problems that actually talk about oranges and apples and things into percent sentences. So this will start out being a kind of problem to solve, but soon it will be a tool in our toolbox that we use to solve bigger problems. Ready to start? Okay. So we have two ways to do this: the translation method and the proportion method. You don't have to learn both ways. For the gazillionth time, I am telling you in this class that you should be able to follow both ways. So if an instructor or a classmate that you're working with does the way you don't like, you can follow what they're doing. But on your own work, you only have to do one of these. The translate way just translates these problems in exactly the same way you're used to doing all word problems. So some people will say, ah, this looks nice and familiar, it works for me, life is good. What is what you put your letter on? I like Y's. You can do X's if you want to be risky and have them look like multiplication symbols. Is becomes equals. We just talked about riplop. I have a percent here, so I'm going to go out of percent. So that means left twice. Of means multiply. And 60 is our number. So whatever that is, 0.35 times 60. 21. And if you are very awake, you will say, wait a minute, we just did this with the percent of. Why are you teaching me something with y's and so on? I didn't need y's over here. You're making it complicated. And the answer is that it's not always true that the what is going to be by itself. We might have 60 as 35% of what or something, and this will still work. I'm just starting with the simple case. We'll do more of these in a moment. The proportion method sounds really complicated, and it takes too many words for me to paste legibly. So I'm going to paste it illegibly. Yeah. That's just a reminder that if you like this, go to where we are and read this thing. I'm going to take the same problem and show you the proportion method because it only makes sense if you see it anyway. So the first step is to write out fraction bar equals fraction bar, just like any proportion. Write the skeleton of the proportion. Fraction bar equals fraction bar. Then by convention, we take the left side and make it the percent. 35% is the same as 35 over 100 because percent means over 100. It means some other things too, like scoop decimal points, but that was a nice one. Put it over 100, that's what percent means. Make the left ratio represent the percent, write the value over 100. If the problem didn't tell us the percent, if it was 12 is what percent of 90, then that would be where we put our y, because we don't know what goes there. We'll do some like that. The third step, the bottom right is whatever comes after the word of. So I find the word of, and stick it there. So of 60. Then there's something we haven't used yet. The last thing we haven't used goes in the top right. In this case, the thing we haven't used is the what. So that's what we'll put here. Then I do my proportion, y times 100 equals 35 times 60. Y times 100 is 2100. Divide both sides by 100. And I will again get y equals 21. Okay. Notice on this side that there is no riplop. Instead, we are making over 100 be our percent sign. We have different ways that we can do things with percents. And if we do the over 100 way, we don't need to do the riplop way. If you like riplop, then you're going to like this side, the translation method, because you write less on the page. Riplop is sort of doing things in your head. There we go. On the other hand, if you like cross multiplying, then hey, I can cross multiply. You'll like the proportion method. Ready to do a bunch more example problems? Okay. Somebody do this for me. Let's start with the translation method. How do I translate 12 is what percent of 5? It starts easy. The 12 doesn't do anything. It just stays 12. Sure, Rick, your hand is raised. Go ahead.
So 12 translates into equals,
12 translates into 12.
right?
Translates into equals. What?
What is our variable? So that would be y.
The word percent you don't translate into anything.
I'll leave it as a percent sign for now, perhaps.
No,
What?
don't even put a percent sign.
Okay. Of is multiplication times.
And 5 stays 5. Everyone with me? Thank you, Rick. Okay, I have something attached to y with times 5. We've done this already. Get y by itself is divided by 5. Whatever that is. 2.4. Now I had ignored that word percent. It's instructions at this point. They want a percent answer. I have a decimal answer. So I need to go into percent format. So write into percent, and I get 240%. Does that sound like a reasonable answer? 100% is the same as something. 200% means double it. Is this like double and then some compared to 5? Yeah, this is double and then some. So that sounds right. Okay, proportion people. Somebody call out what I do here. Start with the percent goes here. What do I write?
Is it gonna be 12 over 100?
It's something over 100, but not 12 because it's not 12%.
It'd be y over 100.
Yeah, I don't know what the percent is. It's what percent, right? Then I had something that goes after the word of, that goes down in the bottom.
Five,
5, and the number I haven't used yet,
12.
12. Okay, everyone okay with that process? It's sort of like Mad Libs, but not as funny. Okay, then I cross multiply. Y times 5 is 12 times 100. I am probably writing more than you would. Now I get 240. I've already paid my dues for percent format. I've put something over 100. So I can just slam a percent sign on there. I don't have to pay for it by doing anything. I've already done that. up here. Not sure why I put my box in green. Everyone okay looking at both sides of this? Everyone okay trying to do one or the other, but not necessarily both on your homework? So we started with a what in the beginning. We just did a what in the middle. To be thorough, let's see what happens when you have what at the end. Oops. Okay, translating. Anyone want to be brave and do the translating, or should I this time?
So I think the 5 would stay the same. So it'd be 5 equals.
You're doing in or out of percent?
Out of the percent?
Yep. Out of percent format, go to the left. Okay, keep going, Maria.
I lost it now.
Would it be 0.02 y?
0.02 of is times and then y. Another bunch of times where be careful your decimal point and your multiplication dots don't look too much the same. However that works for you. Maybe you use X's, maybe you're just careful. Okay, something is stuck on to y with times 0.02, so I need to do divided by 0.02 to get rid of it. Does dividing by a tiny little thing make things bigger or smaller? We did that earlier with powers of 10.
Bigger?
Bigger. So 5 divided by 0.02, 250. That's the answer. Does that make sense as an answer? 2%, so more than 100th, but not a lot of this is 5. Yeah, depending on your mental math, you might say, well, 1% would be 2 decimal point scoots, that's 2.5. So when I double it, I get to 5, or maybe it's just sort of seems close. But yeah, that's okay. Proportion method, fraction bar equals fraction bar. Somebody tell me what to do.
The left side, the left one is the percentage. So it would be 2 over 100.
Mhm. Then I have of something.
So then the what would be the y on top, bottom.
Bottom. The of thing goes on the bottom.
Okay, then
It is
5 goes on
easier if
top.
you have the list in front of you, but I don't. So unless you have notes in front of you, you have to just memorize it. Okay, and the thing we haven't used yet,
Is 5.
5. So this should be in your notes if you like this process. And again, you can use your notes on the test. Okay, we've set it up. Now we multiply y times 2. I'll take the diagonal with y and do that on that side because I like it. If you are not going on into higher algebra type classes, there's that shortcut where you multiply the two that are opposite each other and divide by the one opposite y. You can always do that shortcut if you are done here in 52. So hopefully at this point, you can do lots of these percent sentences. You've seen all the different ways they can be. You have one method or the other that you like, and you can do a bunch of homework. If you need more practice, do more practice, look for things here, watch videos, blah, 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 blah. So finally, we get the cute sort of wonderful thing. We can treat this like Mad Libs. That's going to be too big. So something is something percent of something else. This number is the part, the change, the new amount. This is the percentage, and this is the whole or the original or the baseline based on your word problem. And if you are a proportion person, then you can take this and make it like a proportion. Instead of writing it in this format, which is ready to translate, then you say, the thing after of is going to be my whole amount, my original, my baseline, this number. The percent is going to be the part of the whole represented as a percent over 100. And the thing we haven't used yet in the top corner here will be my part, my change, my new amount based on how the problem is worded. So the rest of the trickiness of word problems with percents is how to read a real paragraph and change it into this little Mad Libs game. Or change it into this little Mad Libs game. If you don't know Mad Libs, then look it up. It's where you plug things into blanks. So let's do a few, and then I'll see if you have other homework questions or you want more of these. So I'm actually going to open that in a different window so that I can make it not as wide for copying and pasting. Okay. So somebody's car can drive that many miles on a full tank of gas. The gas tank is 15% full right now. How many more miles can he drive before he runs out of gas? So I want to say something is something percent of something. And this one, let me write that better, because I'm going to be writing that a lot. I should write it well enough to copy and paste it a bunch. So this is my part, my change, or my new amount. This is the percent, obviously, and this is my whole, my baseline for a change, my original compared to something new. I will keep using that again and again. Okay. So what numbers fill in the blank for this problem?
The whole would be the 396 miles.
Mhm.
And obviously the 15% is the percent.
Yep, the percent's usually the easy one. And then the thing we don't know, we'll just put what. So we're really asking, what is 15% of 396? If we were going slow in Math 20, I would solve each of these, but I'm going to assume that you can mimic what we've done and actually do the solving yourself when you need to. If not, holler. I can always record myself in YouTube, just doing more of these if we need. Okay. Do. Let's keep translating. During the school year, Eugene has a population of 180,700. The U of O has 20,600 undergraduates. What percentage of the school year population are undergraduate U of O students? So we're just filling in the blanks.
So the 180,000 would be the whole.
Mhm.
I think the 20,000 would be the part,
Mhm.
and the percent is what we're looking for.
Right.
The what? Yeah.
You could take it from here. Sierra and her sister enjoyed a special dinner in a restaurant. The bill was $41.50. She wants to leave 18% of the total bill as her tip. How much should she tip?
So 4150 would be the whole. And then obviously the 18%. So the part would be the what?
Yeah. One serving of chocolate frosted sugar bomb cereal has 7 grams of fiber, and the box says that's 29% of your recommended daily amount of fiber. So what's the total recommended daily amount of fiber?
So it would be what?
Which one is what?
The first one. Is it out?
No, the part that we know is the 7. This is a part of your daily fiber. So that one's actually 7.
So the whole would be the total recommended amount of fiber.
Yeah, that's the total. That's what we don't know yet. So that's the what. And then the percent is the 29.
29 would be, yeah.
See the difference in this one? They're telling us a smaller amount and wanting a big total. They're telling us a part and wanting a whole. Okay, I'm going to try and trick you with this last one. Remember Journey's warning from earlier in class. Okay, Rick, you have your hand up. Let me know.
So since we're wanting to solve for the percent decrease, we're trying to solve for the change. But the very first step is that we need to subtract $3.64 from 371 because that's the actual change. They haven't given the change to us. They've given us the start and the end figures.
Correct. So that's going to be 7 cents.
So the 7 cents becomes part change for this to the left.
Right. So that's the part.
Percent is what we're solving for. So that's the variable. What? And the whole baseline is, I guess, 371 because that's the start of the
That's
whole.
the old one, right? Going back in time, history, that's the old one. That's what we compare things to. Everyone okay with that?
That one was confusing.
Okay, let's go back to here. Calories in food, I'm not encouraging you to do unless you want to, but if you like looking at nutrition labels, the textbook has some examples of that too. Okay, let's go to your book and make sure that you feel ready for. So percents are on page 149. Okay. So welcome to the book talking about percents. It's asking you how to do things like fractions to percents, how to do percents to fractions, decimals to percents, all this stuff, how we started in the beginning, percents to decimals. So hopefully their example problems will complement what we did, and then you can just do a bunch of them. 5.2, you're solving percent sentences, and they're telling you the translate method. They have this thing of what they're calling basic percent equations. What is an of without all of the rest of the words around it, what I just called percent sentences. They never show the proportion method, so shame on them, but do either way. And then they're trying to do what we just did a moment ago. They give you a whole paragraph and you try and turn it into a percent sentence. Fill in the blanks with the first, second, and third blanks. They talk about percent increase and decrease last instead of earlier. Just use that formula if you want. And then they have a whole bunch of word problems. Now they have proportions. So here's the proportion method. They show you lots of things, and then again, a bunch of problems. The last is these tables, and the goal is to fill up the table so that all of the amounts in the value column, is it going to let me highlight it? No, let me just grab one of these for the board. The goal is to take these tables and fill it up so that everything adds up to 100%. So you need to fill in the stuff over here so the total is 100%. So the examples are pretty good. Work through following what they're doing. I don't have time to try and go through that now. And there's not that much there. And that's all there is to chapter 5. Oops, I forgot to share back to the thing. But anyway. Okay, should we do one more or two more of those, or do you want the end of justice ratios homework before we're done with recording in 120?
I feel like more ratios would be not that good versus more percents.
More percents? Okay. Let's look at the percent homework ahead of time. So I am sharing my screen for the 10 exercises about the thing we just did. Notice there's also random problems too, as much as you want to practice. But pick one of these 10 that we'll work on ahead of time for you.
I feel like even just reading the first one, I don't know how I would do it.
Okay, well, let's start with number 1 then. You could do this with translate or proportion. I will do both, you don't have to. If I'm translating, I'm going to translate the number is the percent number of, and what? This word number is just sort of filler, right? And I'm going out of percent. So I'll take that 64 and scoot left twice. Everyone okay with my setup? So 56.32 becomes equals 0.64 of becomes multiply, and what? I have something stuck on to y with 0.64, so I'll divide by 0.64 to clean it up. So whatever that is, I will get my answer. 56.32 divided by 0.64, so 8,800. Whoops, no, I forgot. There we go, 88. If you're a proportion person, what number goes on the left side?
The percent part, so 64 over 100.
The thing that comes after of.
Thing that comes after of is the bottom of the right side, so that's our variable.
Variable of what? We don't know what it is. And the thing we haven't used yet, 56.32. Cross multiply and you'll get the same thing. If I'm doing the shortcut, then that would be these two I multiply, and this one I divide. How about one of the word problems? I don't want to finish it for you, but we could set it up.
Number 4.
Number 4, okay. Narrow for a moment. So this one's a little tricky.
Are you gonna minus the 245 minus 203?
Yeah. Some people might have added the 4 and the 38 going that way. It's either way. This is the total number of people that didn't complete it for one reason or another. Okay, the percent it doesn't give us. And then the whole amount is the 245. Okay, I'm going to stop recording for now. If you want me to go over